continuing with our review. And the exam, by the way, will be drawn a lot from the quizzes that you've done. And it's going to be also over the stuff that we have done in class. I know that's kind of vague, but everything that you've done in homework is fair game. Also, you're allowed to use all your notes, any of the PowerPoints, anything you've created and uploaded. And let's see, did I make a folder yet for you to upload your own notes into if you so choose? Yeah, upload any notes to the exam here. So you can put anything you want to there. You could even, copy and paste every single note, file that we've written into a giant Word doc, so you can Control F through it or whatever. On the other hand, the more information you have, right, the less you can overwhelm yourself. You're not going to have to write an entire program, but I may ask you to write code snippets. As a matter of fact, I'm sure I'm going to ask you to write code snippets. Anything you write, it's not going to require idle to do, but I don't mind if you load up, idle and create a file in order to spot check your syntax, but I'm not going to count you big off, if you put in a period rather than a comma or whatever, as long as I can tell that you know what you're doing. So on to our Python for Everybody website. I thought I'd posted a link to it. I don't see the link to it in here. Is it in class information after all? No, all right.
It's on the home page.
It's on the home page? Okay.
Instructor announcements.
Okay, cool. I'll also stick it in class info. So functions. A function is a block of code, a named sequence of statements. So when we define the function, we specify the name, and then we give the sequence of statements. Later on, we can call the function by its name. There's lots of built-in functions. Yes, yes I am. Let me make doubly sure, triply sure. Yes, sir. Alrighty. So, they've demonstrated a function called type. The functions that we've used the most often are float, int, print, and input. I don't think we've used a lot of others besides that. And the range statement is sort of a function as well. So when you call a function, you may need to give it an argument. The argument fills in the parameter variable that you used when you defined the function. Now we didn't define this one. So you give it a name, you give it a parentheses. Inside the parentheses, you provide any necessary arguments. So we're going to write a function called double, which takes a variable and returns twice that variable. So the function name is double. The parameter variable, usually just called the parameter, is x. So when we call it, y is equal to double times 10. Then after we're done with that, y is going to equal 20. So 10 is the argument value, or just argument, that fills in the parameter variable. Bless you. You can also provide default values for parameters. Like this. Now for whatever purposes, we've decided that if somebody wants to call the triple function, they don't have to give a value. And if they don't, it will default to being 10. So the x parameter has a default value. We're going to shorten this one, just return 3 times x. So if we print triple of 4, it's going to print 12. But if we just print triple and don't provide an argument, then, okay, this is dumb. I made a mistake. No, I did fine. Sorry, I was looking at the wrong thing. So here's our two functions. I'm going to cut and paste that to put it above the, so all my functions are up at the top, at least for the moment. All I did is I moved triple up there. So no default, no argument specified. So the default value will be used. Oh, bless you. So since we're not giving a value, it's going to assume that x is equal to 10, and it's going to return 30, so that's what we're going to see from the second print statement. And that's, in fact, what we see. Now that's slightly silly, right, in this particular case, because if you're going to call a double function, it's because you probably want to double the value, or triple, or whatever. But it's demonstrating. So you can, as well as providing parameters, arguments, or letting them default, you can use what are known as named arguments. And the named argument is when you specify what variable gets filled in with what. And I'm going to give you an example of Python using named arguments, named parameters. If we print something, hello, and then we print out, Bob, like that, it's going to print out hello on one line and Bob on the other. Now you may have used some programming languages that did not always do a new line after every print statement. Sometimes you don't want to do a new line after every print statement. Well, what we can do is we can provide a named argument. End is equal to quote space quote, or quote comma quote. What this does is it replaces what normally ends the print statement, which is a character return, with some other character, in this case a comma. And so it printed out hello Bob. Now the syntax looks funny, but what it really means is that there is a parameter variable named in the print function. So def hello, we're going to say hello to somebody and say their age. So we need two variables, name and age. Print parentheses quote. Hello in quote comma name. And then print you are %d years old, because that's what I like people to tell me as soon as I meet them. You're %d years old, end period, end quote, and then we're going to fill in that placeholder, that %d placeholder, with the age, so %age. Now when we call it, we can call it like this, hello Joe who is 18, but we could also do this, hello age equals 20, comma, name equals Bob. We're giving them in the reverse order. That's okay. Especially if these things had default values, that might prove to be useful. So we could make a parameter variable list, that had 5, 6, 7 different values. Give them all default values, but they could override them. if they wanted to. Now I'm not going to give a demonstration of that. I guess we could give one demonstration. Let's give name a default value of empty string. So to just say hello if they don't have an age, excuse me, a name. And so hello, we're getting even older. Age equals 30. What's it going to do? It's going to jump up here. This argument fills in the age variable. We don't have an argument that fills in the name variable, so name is going to be blank. Tell you what, just to make it absolutely obvious what's going on, our default name is going to be blank. And it's going to break. Non-default argument follows a default argument. That is true. Once you provide a default value, then the rest of the parameters in the function also have to have default values. So, since I added one here, this one also has to have one. Why? Because if we just passed in one variable, it wouldn't know which one to fill it in with. Alright, so it says, hello blank, you are 30 years old. The name argument was not provided, so it reset to its default value, and we did provide an age variable, an age argument to fill in the age variable. So, fun with parameters. They get filled in with arguments in the function call. They can have default values defined in the function header. And they can be filled in directly from the function call by name, such as hello parentheses age equals 30, like that. I mean, they're always filled in from the function call, but they can be given the names, and then the order does not matter if you're providing their names, right? Here, the arguments are coming out of order because this was defined as name and age, but that's okay because we're specifying which one we want to fill in. Expanding our comments a little bit, I'm going to give an example of default values in the function header. We had decided that we could have a variable that defaulted to 10. So, if no argument is specified, X defaults to 10. Anybody need syntax errors? I know that I was going back and I was editing code, and that's usually a recipe for disaster. All right.
Can you go back down?
Here? Yeah, for the notes. We good to go? Or still catching up? Almost caught up. Cool. Wrong. So built-in functions. There's one called max. There's one called min. Now I love max as a variable name, so I kind of wish that it wasn't a function name as well, but it's obviously a very nice function name as well. When you're typing into idle and it highlights a word in as a separate different color, like this, max equals 3, but that turned purple, then just know that you are resetting the reference to that function, that there is a function named max, and that we are resetting it. It's not a real big deal unless you plan on using that function later. Like if you did this, print is equal to 3. That is a fairly significant thing to do because then printing will no longer work. Don't even type this unless you just want to prove to yourself that it doesn't work. So this is just about the only no, I won't say that, but most languages, many languages will not let you redefine a function reference, something like that, that breaks the function. But there are min and max functions, which will return the smallest or the largest of a sequence. A is equal to min, and we're going to give it a list of values. 8, 6, 7, 5, right? The minimum of that's going to be 5, and I forgot my close brace there. And then B is equal to max, parentheses, square brace, 3, comma, 0, comma 9. And if I print this out, it's going to say that the minimum is 5 because it searches the entire list, and that the maximum is a 9. So the min and the max functions work on both strings and on lists. Right, C is equal to max, parentheses, quote, rows. Well, the largest letter, its ordinal value, its position in the alphabet, is S. And so at this point, C would equal S. Whereas at this point, what would B equal? What's the maximum of that list? 9, and then that means that the min would be the 5 in this one. So these are built-in functions. We didn't have to bring in the math library in order to use them. There's also a sum function. I've been making y'all write summations, right? But if you'd stored the values in a list, then you could just call the sum function, which looks like this. D is equal to sum, parentheses, angle. Let's put in some numbers, 1, 2, 3, 4, 5, like that. In parentheses, end angle, like that. Now your summation loop could have been replaced with a single line of code. And I don't want to kind of harp on that, but say that you had an upper value set to 10 because you wanted to do a summation from 1 to 10. You could make a list based on that. L is equal to the list of the range of numbers starting at 1 and going to upper plus 1. Now why plus 1? Because it defines 1 past the end of the range. You want to count to 10, you better make this 11. And then you could calculate the sum. You know, total is equal to the sum, parentheses L in parentheses. And you could combine those two statements if you wanted to into one, right? Because this is just creating something. All of this returns something that is stored in there. And then that is being fed into that. So although it's going to look stupid and long, and you could do the sum of the list of the range of 1 comma upper plus 1 close parentheses, close parentheses. How many close parentheses do I need? 1, 2, 3, like that. And so that one line of code would replace our loop. Whatever. You have to know how to write loops. But Python quite often gives you an extraordinarily terse way of solving a problem. And terse, I mean, you know, as few lines of code as possible. Now, my goal in life is not to write the most terse code possible because it can be more difficult to understand. However, if you look at this and you're used to what the range statement does and you're used to the idea that you can convert a range to a list and you know what the sum function does, then that actually kind of makes sense. Now, could we do factorial? Could we do multiplication like that? No, because there is no function which multiplies all the numbers in a list. We could write a function that did that. It would have to take a list variable and it would have to iterate through them all, multiplying them all together, let's just leave it as is. So we've seen some functions. We've used the built-in functions. Well, at this point, we've seen min, max, and sum, but those are pretty much new to today. And then list, and range, and then print, and input. Seemed like there was one more. Oh yeah, int and float. A lot of these we've been using all along, specifically those. We didn't start using range until we started talking about loops. And the rest of these are pretty new. So, am I going to ask about min and max and sum on the exam? Nah, not unless they were questions in the book exams, and I don't think they are. There's lots and lots of built-in functions. One textbook I used annoyingly called them BIFs. Yeah. Hey, here they are. Absolute value, delete attribute, all. I don't know what half of these do. Don't know what all does. Memory view, don't know. Returns a memory view object created from the given argument. See memory views for more information. Yeah. Okay, whatever.
That be like a memory address?
I'm wondering. Why not? Let's just throw it in and see what it does. Like if we have a string called name, and we print the memory view of that. I have no idea what it's going to do. Alright, it's a byte-like object. Is an integer a byte-like object? Whatever. I'm not going to mess it in anymore. If I wanted to learn more, I would find some examples of it. I would read the documentation. The min, the help function gives us information about the function that we're trying to use. That sounds like a tautology, but let's take a look at it. It's not the one that I want to close. So if I go to the shell here, and I want to learn more about the memory view function. Help memory view. Nope. Help. It's a function. The help function is a function like everything else, so it needed the quotes. Memory view. And so here's all the things that it can be, or what it's supposed to do. Creates a memory view object, which references the given object. Yeah, we could learn something from that. It's a little bit over my pay grade at this point, but I'm curious. I will learn about it at some point. The help of the sum function. Pretty neat. Let's run our code. And I think we've demonstrated this in the past, but after we run our code, those functions remain in memory. So we have a double function that I could call. I want the double of the value 100. It'll print 200. Okay, that's cool. Tell me more about my double function. There's no help on it. I could add what's known as a DocString to my function so that if I ever typed help double, it would give me some hints about how to use it. I'm not going to scroll back up and do that, but let's write another function. def times 10, parentheses x, in parentheses, and here's the DocString. The DocString is another use of the triple quote. Times 10x returns 10 times the argument. Like that. And then return 10 times x. Now I'm not going to even call it, but I am going to run the code which loads that function into memory. So if I do help parentheses, I'll bring the code right back up, times 10 in parentheses, it tells me what the function does. Times 10x returns 10 times the argument. If we were pro programmers, we might consider putting a docstring inside every function we write. Documents what the function does. And for our short little 1 or 2 or 3 line functions, the purpose of them is pretty simple. But as you go on, your functions are no longer going to just be 1, 2, or 3 lines worth of code. I should make it mandatory that you provide a docstring for every function you write. But if I ever make that decision, I'll make it real blatantly clear that I've done so. So let's add a comment. The above is an example of a quote docstring that can be displayed by using help parentheses times 10 in parentheses. The len function will return the length of the list or the length of the string. So len of hello world, 2 5-letter words plus a space is 11. If I did that len 8675309, well, that's supposed to be a phone number, it would be 7. Type conversion functions. int of 32 will return a 32. Because that string gets cleanly converted into an int. However, if you do something wrong, like you've specified a decimal point or you put some letters in there, then int will return an error. However, it's got some additional functionality besides that. It can support other bases. Like if you're going to write a program that needs to convert from hexadecimal to integer. Now, I haven't really talked about what hexadecimal is, but it's a numbering system that uses the letters A through F as additional digits. And where have you seen hexadecimal before? You may have seen them as a way of specifying IP addresses. Probably not. 128.0.0.1, something like that. But you may have seen something like FE colon, if you've done system administration, 32 colon 09 colon A1, whatever. And you could translate that. Well, what that is it's just like an IP address in that every value in here is a value between 0 and 255. Colors in the RGB color space are sometimes specified using hexadecimal, because if you use RGB, red, green, blue, the luminosity values of the pixels, you know, if you had 3 pixels making one color, then each one of those can be arranged from 0 minimum up to 255 max. And so often the colors will be specified by their letters rather than their numbers. Let's look up RGB HTML. And there we go. RGB of 25500. That's the max value for the red, so it's maxed out. Well, FF in hexadecimal happens to equal 255 in our counting system. And 00 happens to equal 0. Alright, so let's change it up a little bit. Red, green, blue. If we max out the blue as well, just like when we were kids, added our red paint to our blue paint and we got purple. Now, unlike when we were doing kids, in terms of pigments, you use yellow, but when you're using luminosity, when you're using light, we don't use yellow, we use green. And so if we were going to max out the red and the green and the white, what's it going to make? Well, they're all three at their maximal values, so the pixel's going to be full on, going to be white. What happened if we lit up the red pixel and the green pixel completely, but left the blue one 0? Well, now we get yellow. That seems counterintuitive. I added red and green and got yellow. Well, okay. Let's say that I took the first one to 0. This color has no red, but the green pixels are on at max value, and so the blue ones, you get cyan. And you get the idea. You can get a single short representation of a color that is composed of 6 hexadecimal digits. So suppose we wanted to write a program that would ask the user for a hexadecimal value, and we would convert it to a straight decimal value, right? Because I'm curious about what that FF means. I don't know what FF means. I want to find out. So, my string is going to be equal to quote FF, and I'm going to convert it to a decimal value so I can print its number out. Now, I happen to know that FF is equal to 255. We're not here to learn about how to convert hexadecimal to decimal. I just kind of want you to know that you can. I mean, I guess we could devote a lecture to that. That's more basic fundamentals, but on the other hand, half the class hasn't taken my fundamentals class, and I don't think they talked about it in Donna Wilson's or anybody else's. So anyways, x is equal to int of that string. Well, that's going to blow up. That's going to be a syntax error. Because it doesn't know, that's an invalid literal for base 10. Well, what if we're not using base 10? What if we want base 16, which is hexadecimal? I'm going to go back and put a comma 16 there. And now let's put a print statement. %s hex equals %d decimal. End quote. Percent open, close, and inside that pair, we're going to fill in the placeholders. The %s placeholder gets filled in with that. And the %d placeholder, which just stands for whole number, gets filled in with x. And I know that in one of Kendui's classes, you wind up writing a Python script where you can use command line arguments to figure out the hexadecimal version of a number, the decimal version, the octal version, all sorts of different versions of it. And this is one of the tricks that you have to know how to do, is to specify the so-called, well, this one's calling it a base, so that's good enough. You have to specify the base. What if you need to go the other way? What if you need to convert what if you need to convert 255 back to a string? A darn good question. Python format string hex. Cheating it out. Cheating. Okay, you just use %x. Okay. So we're going to go the other way. If our number is 10253, I'm just making that up. Who cares what it is? And then I do that my string is equal to quote %x end quote followed by a %sign. Now this syntax looks horrible and we should be using dot format instead, but I'm going to roll with it anyways. Like that. This takes x, and just like we were printing it out, It converts it using this placeholder. Now %x as a placeholder means hexadecimal. So when we print it out, I'm just going to copy this statement and paste it. That's easier to do. And here we go, right? That was my number, that was my input number, and it turns into 280EX. So I'm going to add some comments here. This INT converts string S hexadecimal to an integer. And this statement converts X to a string in hexadecimal. So what is this syntax doing here? That looks kind of ugly. No ifs, ands, or buts about it. But what it's doing is just like we were doing this, right? %x hex equals, we were filling in placeholders, except we left out the word print. We could take this line of code right here, copy all that except for the closing angle, parentheses, and we could store that in a string. Output equals like that. And that's valid code. Then we could turn around and print that output out. So the string object supports that operator. And when you use it like that, you have to then follow it with the parentheses and a list of values that are going to fill in the placeholders. Now you can skip the parentheses if you're only passing in one value. But otherwise it would look like that if I was going to be passing 2, 3, or 4 different values in. And it's okay if you're not getting this 100%. If you're even getting this 25%, that's good. I'm expecting some of y'all to be getting it completely and some of y'all to be getting it only a little, and that's okay. I'm not expecting y'all to be busting out with this syntax in order to print your output every single time. I do want you to know how to use printf with placeholders, though. Not printf, I'm sorry, that's a Java term and a C term. To fill in, right, and the use that we've seen most often for that is %f, right? Print cost equals, %.2f, meaning I only want 2 decimal places. End quote, and then %, and then the number, the price that we wanted to print out. Now I don't have a price variable yet, so that would be a syntax error. So I'm going to go up here and add a price. My price is $1.20. But when it prints it out, it's going to print out 1.20 because here I have specified 2 decimal places. I really want you to know how to do this. The question could be formed in as, on an exam, it might be written like this. Write a print statement that will print the value of X, forcing the display to show 2 places after the decimal point. And what would the answer be? The answer would be print, parentheses, quote, 2 places after the decimal point. That means it's a floating point number, %.2f, end quote, comma, X, like that. That would take X and it would format it to print out in that specific format. We do that so often that I really want you to memorize it. Why do we do that? Well, to display something in dollars and cents. You don't want to say $1.2. We like seeing that cents displayed, 1.20. And otherwise, if you have 1.666, out to 18 digits, you might just want to display 1.67. Or, round it to 3 decimal points, right? Or 4 decimal points. Something, less ridiculous than that absurd amount of accuracy that it's trying to show us. So we've seen int, and then there's float. I believe float has the same ability to specify a base, but honestly I've never seen anybody who wanted to provide a hexadecimal value for a fractional number. I'm sure there's a reason to do that. But if you have an input string that has a floating point value in it, like that, we can convert it like that. Or whenever we've been getting our input, right, enter the maximum value, the upper bounds of your summation, something like that. We always displayed a message, enter the upper value, and then we got the input, upper equals input, and then we converted that. Upper equals float of the upper, right? I also want you to know that. And so how would that question be worded for an exam? Write a statement that prompts, or write statements, write code that prompts the user for a value, gets the input, and converts it to a float. I might be more specific. I might specify the message that you're supposed to be prompting for, and I might specify the name of the variable.
Turning that down to one statement.
Yes, you can, if you know how to do it, and I'm going to demonstrate it, this could easily become one statement. So, the message to display in this case is enter the upper value, and the variable to hold the result is upper. Except I wouldn't put quotes around it, but I might italicize it or something like that. And just like you said, you definitely do not have to do it in 3 steps. You could do it in 1 step. Since you mentioned it, how would I do that?
Say upper equals float, input,
Parentheses, quote, enter the upper value. Both of those work just great. Now, if this was for the summation code, we would want to instead make it an int. Why? Because the easiest way to do the summation is with a range statement, and range requires integers. We've been using float just because it's slightly less error prone. So if we ask for somebody's weight and they feel like typing in 125.5, then it won't crash. But turning something into an int is just like that, right? And so in that case, the question would change into that. All I did is I replaced the words float with int, and now it gets a whole number. I'm going to undo those changes, though, since my documentation said float. But I could ask. Or the question could ask for int instead. And then the string function does the opposite. It takes a number and turns it into a string. So if our number is 123.45 and we want to convert it to a string, we could do so. S is equal to str, parentheses, in parentheses. Now, why might you want to do that? If you're creating a graphical user interface, in some languages, in some environments, everything you do has to be done with a string. You have to convert it to a string in order to display it, and you have to get it back. You have to convert back from the string to an integer form in order to process it. Now, I don't think, I'm pretty sure that Python has ways of avoiding doing that. It's one of the rare frameworks that supports directly linking of a control, like a text input field, to a number. Could be wrong about that. But we will get there when we talk about building graphical user interfaces. Another reason to do that is for more finely grained control of the print statements. Because, as we know, if we put commas between everything, print n equals end quote comma n, like that, it's going to put a space between the equal sign and the variable. We may not want that space there. Print parentheses quote n equals end quote plus, and then we need to convert that to a string, ignoring the fact that I already did that there. str parentheses n end quote like that, two closing because we had two openings parentheses. This will print it out without the space after the equal sign. So commas, add spaces, unless you remember the name of the parameter to override, like I did with the end equals parameter name, and I don't. And if you want to avoid that, you can use a concatenation operator instead. But to do that, then everything that follows it has to be a string. If I try to do this, although that would work in Java because Java tries to convert everything to a string automatically, this would not. So I'm going to go ahead and do that again. So other things to know. Plus means addition, but used with strings is called concatenation, which means appending. So if you have this, s is equal to 1, 2, quote, plus, quote, 3, 4, and then you print s, is it going to print 46? Because 12 plus 34 is 46? No, it's not going to do it. Instead, it's going to append those values together. S will equal 1, 2, 3, 4, like that. So random numbers. The version that the book showed us was to use rand int. The random library, the random library has a whole bunch of different functions, so besides rnd int. Here's one just called random that generates a number from 0 up to but not including 1. So if you want to generate a random floating point number from 0 to 1 non-inclusive, then you would call that. Now, how many times do I want to do that? Rarely. I like whole numbers, right? So I would use random int. Well, let's make sure that we remember how to do that. We want to add 3 dice together. Well, we better import from the random library total equals random dot rnd rand int parentheses. We want our numbers to start from 1 and we want them to go up to 6. Now, unlike the range statement, it's actually inclusive, not exclusive. We would not do 1 to 7 to get 1 to 6. Plus another one, plus another one. Why don't we store those three things into 3 different values, right? A1 is equal to that, and then I can just copy and paste that to A2 and A3, and then I can make a total that's equal to those things. Total equals A1 plus A2 plus A3. So I could ask you a question, like, write a statement that determines, picks, creates a random number between the values of 1 and 10, right? Storing it in a variable named num. Or maybe we're going to make it say write statements that create a random number. And so I could add this to my test question. Include the import statement. Now we've already given that example up here, but I'm going to do it again. Just because this is a demonstration of a question. So import random, and then num equals rand dot next int parentheses. What should my first number be? 1. What should my last number be? 10. And that answers the question. Except I've made a hideous error. Does anybody see my error? This would crash. It would tell me that already. Pardon?
Next 10. That's Java.
2 hideous errors. Next int is in fact Java. All right, here's what this really should be. Sorry about that, guys. It should be exactly like it was up here. Random.randint. Please correct your notes so that you don't get it wrong and then blame it on me. Now we're at the point, since the program is asking for input each time, that it's getting annoying to, I never printed out the total. I could ask that to my question, add that to my question. You should know how to print a message. Or I could have printed out num. What if you do not like prefixing your function call, your method call, because a method is a function that's attached to an object? You could have done this instead. From random import rand int, and then just do num equals rand int parentheses 1 comma 10. So either one of those would be valid answers for that question. This is easier to write, right? Kinda. I don't know. Go take a look at another version, or more functions available to us. Python random. You can get a range, return a randomly selected element, that's interesting. To me, it looks like next randint. Oh, what do you know? There it is. But random range allows you to specify a step. What if you wanted to pick a random number between 10 and 100, but they all had to be evenly divisible by 10? So a random number between 10, 20, 30, 40, 50, 60, 70, 80, 90, or 100. Then you could use rand range. Its starting point would be 10. Its stopping value would be 100. And then the step would be 10. Well, obviously it's a very powerful library, and I do not understand all that much of it, because I haven't needed to use it before. Here we have made something called choices. The first element in the choices array list is a list, so it's a list inside of a list. And then the second one is a series of numbers, and then the third one is a named variable. Not quite sure why. Let's ignore that. Get back on track. choose an element from a sequence at random, you can use choice. So if our cards are, Jack, end quote, comma, and that's a square brace, Queen, end quote, comma, King, end quote, comma, Ace, end quote, square brace, and then our string could be random dot choice from the cards. Pick one of those cards, and then if we printed it out, it would print one of those values. Hopefully it would print a different value each time we ran it. Well, not every single time we ran it, but nothing that we could predict each time it ran. That time it printed Queen. That time it printed King, and so on. Then the math functions. There's the math library. Do import math, and then you can call some of the functions that are available in it, like log 10 or sine. I believe pi is declared in there. So import math, print math.pi times whatever the radius is, 10 to the power of 2, like that. I'm sure the math library is full of all sorts of rich, mathy goodness. Ceiling. Ceiling of parentheses 3.1 would round it up to 4. Ceiling of 3.0 would still be 3. It just rounds it to the next whole number. And then there's also a floor function. Floating point absolute value. Factorial. Hey, cool, we could have replaced our entire factorial loop with a call like that. Floating point modulus. You want to find the modulus of 3.4, divided into 27.2? You could use floating point mod. Here is a good example of a floating point error. If we add 0.1 to itself 10 times, you would think it would equal 1. So A equals 0.1, and then A plus equals 0.1, and then I'm going to copy and paste that 8 more times. Make sure that I got my count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now if I print out A, I would like for it to say 1.0. But floating point math is not precise. It can exist. It can have rounding errors. Why is that? Because representing a decimal, a place after a decimal point in base 2, that conversion from base 10 to base 2, is not exact. And we've already seen, we know from our past schooling that there are also, what are they called? A number that cannot be represented, like 0.333, repeating infinitely, right? It has no end. There's a term for that kind of number. And so that value could not be expressed in base 10 precisely. Well, it turns out that 0.1 cannot be expressed in base 2 precisely, so that when we added a whole bunch of versions, a whole bunch of those together, we got a rounding error. How could you fix that? Well, you could round it, right? You could specify how much you wanted it to be rounded to. Well, that was no good, so A is equal to round, right? A to 3 decimal places. And then when we print A, it's going to look a lot better. I could probably even say I wanted it rounded to 1 decimal place. And why would I say that? Because that's all we're using. So we don't want to know anything after that first decimal place. So this will round to 1 decimal place. All right, it's about time to stop that particular journey. So things to know: order of operations. You know, star star is before addition and multiplication and division, which are before addition and subtraction. Also, floor division and modulus are ranked equally to that. And so, you know, good old PEMDAS. I've said that often enough. So what is x equals 3 plus 2 power star star 4 times 2? Just know how to figure that out. What's the first thing we would evaluate out of the whole sequence? Yeah, we would do the power, so 2 to the power 4, I don't know, so I'm going to switch this around. 4 to the power of 2 is 16, and then what would we do next? Now that we know that that's 16, we would do the multiply. So 16 times 2 is 32, and we would add 3 to that, so that becomes 35. Or if I ask you to arrange these operators in their order, then you would say that that was the top one, that was the middle one, and that was the bottom. Know what that does. Know what that does. That's floor division, which rounds down. What is that? That's modulus. I hope we understand modulus at this point. Know how to use an if and an else, or an if, elif, else. If I ask you to write, write code that will print ice if temperature is less than 32, otherwise it will print liquid. Something like that. You ought to be able to construct an if statement that would do it. Now in this case, there's only 2 cases, right? There's a if and then there's an otherwise. So would you use if else or would you use if elif else? I would just use else, right? There's no third case here. If it was a little bit more complicated, write code that will print A if grade greater than or equal to 90, or B if grade is greater than or equal to 80, otherwise C, right? That would require an elif. If grade is greater than 90, colon, print, parentheses, quote, A, end quote, elif, colon, right. And then you'd put your second thing here, grade greater than 80. Actually, it should be grade greater than or equal to 80. I would not count off a huge amount for missing that, but I did specify it up there. Print B, else, colon, print C. Or, yeah, like that. Know how to write a for loop that counts a range. Write a for loop that counts from 1 to 10. Well, for, and I didn't specify a variable, so I guess you could pick your own. For x in range, what's the second number going to be? 1 comma
11.
11, and then you would print out X. Write a for loop that counts from 100 to 1000 by 50s. Okay? For X in range, what's the first number going to be? What's our starting point?
100.
100, and what's our stopping point? It's okay to say 1000, but you got to go one past it. And then we wanted to skip by 50s each time. About time, getting close to stopping, and we have 8 more minutes. While loops. Write a statement that means while X is less than 10. That was pretty easy. Don't forget the colon. Okay. While X less than 10, right. If you have an equation, area of tetrahedron, oh come on. That's the formula for our area of tetrahedron. I would want you to be able to express that in Python. Now in Python, you're not allowed to leave off you can't just type 3a. You have to put 3 star a. Well, let's take a shot at that. In order to get square root, there's 2 ways to get square root. You could do something to the power of 0.5, or what's the other way? The better way, the way that the book would recommend. Yeah, we could import math. So the formula for a tetrahedron. Now, I don't want you to memorize the formula for a tetrahedron. I should copy and paste that picture into here, and I'll try to take the time to do that. But it's A equals, and let's take a look at it. Let's piece it together. Assuming we have done import math, then we can use the square root function. Math.sqrt parentheses. Now, if I'm reading this right, the parentheses only extends as far as that, right? So we're not going to put a squared inside the parentheses. So we're going to put 3 there. Followed by times a, and then what are we going to put after the a? To take something to the power of 2.
2 asterisks.
Yeah, 2 asterisks. So it's going to be times a star star 2. Like that. It's very unlikely that I'm going to give you the formula for the tetrahedron, right, as a test question. But I could give you an equation like that and ask you to write it as an expression like that. And the big deal to know is to, don't leave out the asterisk just because math textbooks do. Alrighty, know the difference between and or. And requires both operands to be true for the result to be true. Or requires only one operand. And what do operands mean? Those are the symbols, the values on either side of the symbol. So if you have this expression, a plus b, then the operator is addition, and a and b are the operands. So if you have this, if age greater than 17 and citizenship equals, quote, y, the operator is and, well, there's actually quite a few operators in here, right? What are the operands of that one? Age and 18. What are the operands of that one? CIT and Y. Now, what did I do wrong with this statement besides leave off the semicolon? There's a horrible syntax error in here.
You need another equal sign?
Exactly, 2 equals. So the logical operator, though, in this case is and its operands are this and this. Now, I'm not going to ask anything quite so technical on the exam, but I do want you to, the only reason I did that is because I defined, I used that term here. So, if this is and, that means you have to be over 18 and you have to be a citizen. But if we change that to or, then either one of these would be enough to get us into the if body. All right, and then lastly, the not keyword reverses the truthiness. True becomes false, false becomes true. So if A is equal to 3, then what is the result of this expression? B is equal to not A less than 3. All right. Okay, I'm going to change that because I don't want to do the edge case. Is A less than 2? Bigger in life there. Somebody tells me if A is less than 2. No. Okay, so that's a true. But then what does not do? It flips it. Wait, why did I say that was true? A is not less than 2 because I was answering the whole question. So this is a false, but the not turns it into a true. So you could write an if statement based on this. If not A less than 2. However, I would avoid using not, and instead I would just make this if A is greater than or equal to 3. Something like that. Right. This, to me, is easier to read than that. But that's what not does. It just flips it from true to false. And in this language, true and false are always capitalized. So if I'm going to write down 4 pieces of data, and I want you to tell me what types they represent. Which one of these is a string?
True.
That's the string. Right, the third choice. Gotcha. Which one of these is a float? Yep, that one. Which one is a Boolean value?
True.
Yep. And lastly, which one's an int? That one. Yep. Alrighty. Look at your quizzes again. That's a great way to study. Big number of questions will just be drawn from the quizzes. Then other questions are going to be drawn from today's review. And if I don't get it from the review or from the quiz, right? And the review also, counts as last Thursday's review. Then I'm not going to try to make it traumatically difficult, right? But it will be drawn from the homework stuff. So, if you've sweated and, banged your head against the homework, it'll be well burned in. And you can open up your homework assignments and look for answers as well as using the book and the PowerPoints and raising your hand. Just no Googling for answers, please. I hate patrolling the room. I trust y'all. No sending text messages to each other. well, I would notice you using your phone, right? But you could also just pop open Google Chat or something. Don't do anything like that. The only reason I mention it is I've had people do that, and I resent it a great deal. You know, the feeling that I need to patrol because we're all grown-ups. All righty. Any questions? Yes, sir.
Are we going to be allowed to use our laptops, or are we going to have to use the?
I'm fine with you using your own computer because there's not much available on your laptop that's not available on. Yeah. Okay. I didn't make a Dropbox for this. I guess I'm kind of comfortable with not doing that, but I'm going to go ahead and make one anyways. But if you don't upload anything to it, I'm not going to count you off. JKL, because some people need to bail. I went a little too long.